are going to work on 2.2. Direct variation. All direct variations follow the equation y equals kx. Oh, somebody remembers a little something. Y equals kx. In order to find k, we would divide our x over. So it's always y divided by x to find our k. Our k we call our constant of variation. All right. So this is the basics of today. All right. We're going to start off with some easy ones from the tables and work our way through. So first, example number 1. On problems 8 through 10, that's where we're starting at today, I want to know if the table is a direct variation, and if so, what is k? All right, so I'm going to give you a table. This is my x, this is my y. And in my table, let's go with 214, 321, and 428. All right, to determine if it's a direct variation, my k has to match every time. So remember, to find k, we do y divided by x. So I'm going to start here. I'm going to take y and divide by x. I get 14 over 2, which equals 7. In my next one, y divided by x. I have 21 divided by 3. It equals 7. And the next one, y divided by x is 28 over 4, which equals 7. So since they all match, yes, this is a direct variation. And k equals 7, absolutely. Okay? So that's all you have to do for the first couple. Just do y over x and tell me what k is. If you had to write the direct variation equation, it would be y equals 7x. That would fit for every one of these. All right, sample number 2. This is problems 12 through 18. Determine if the equation is a direct variation. And remember, for it to be a direct variation, it has to be y equals kx. So, let's say we'll start off super easy. Let's say I have y equals negative 8x. Is that a direct variation? Is that in the form y equals kx? Yes. And then we can say k equals what? Negative 8. Perfect. All right. What if I had y equals 4x minus 2? Is that a direct variation? It is not. It's got this number added to the end, so this is no. All right, let's get a little bit tougher. What about if I had y minus 5x equals 0? Well, first of all, to determine if it's a direct variation, we have to get what by itself? We got to get y by itself, right? So I'm going to start by moving this 5x to the other side. I get y equals 5x. Is this a direct variation? It is. We say yes. Hopefully we say yes. And k equals 5. Okay? Any question? Awesome. All right. Now to the next part. Finding y varies directly. Okay. Step 1. I want you to find k. Step 2. Write the direct, that's a C by the way, variation, whoops, try that again. Equation. And then step 3, plug in to solve for the unknown. Seems like 3 easy steps, right? Okay. Here's example number 4. Right? Nope, number 3. Number 3. Okay. It's going to tell you y varies directly with x. And y equals 4 when x equals negative 8. Find y when x equals 12. Start off with an easy one. All right, so the very first thing we have to do is we've got to find k. So we're going to use our first line of information, this first line right here, to find k. So I have k equals y divided by x. So my y is 4, my x is negative 8. So k equals negative 1/2. That was step 1. Step 2 says to write a direct variation equation. All right, so now we're going to go y equals, my k is negative 1/2, and x. Step 3 says to plug in what we know to find the unknown. So I'm looking for y, so y equals negative 1/2 times 12. So y equals negative 6. All right, let's try another one. Example number 4. Y varies directly with x. And y equals 5 when x equals, I don't know, 30. Find x when y equals 7. All right, so again, very first thing we do is we find k. K is y divided by x. So in this case, y is 5, x is 30. So k equals 1/6. Is there any question on that step? Okay, that was step 1. Step 2, we plug it into our equation. Y equals kx. Step 3, we plug in what we know and solve for the unknown. So we know y is 7, so 7 goes on this side, 1/6x. How do I solve for x? Or multiply by 6. Times both sides by 6. So I get 42 equals x, or x equals 42. Questions? This is what you are doing for 20 through 26. Well, I got a few more to go. Now, one of the things that is special about a direct variation is the graph of a direct variation always crosses through the origin. Make sure I spell everything right. The origin. Okay, so if I gave you, let's say, y equals 1/2 x, and I said we're going to plot the direct variation. And let's start by doing it with a table. Anytime we do a table, what numbers do we usually use? Come on, help me out, you guys. What do we always use? Huh? Well, we use x and y, but what numbers do we usually use for x? What do you think, Natalie? You're close. How about -2, -1, 0, 1, and 2? Does that sound better? Yeah. All right. So we're going to start by plugging in -2. We have 1/2 times -2 and -1. We're going to plug in -1. We have 1/2 times -1 gives us -1/2. 1/2 times 0 is 0. 1/2 times 1 is 1/2. And 1/2 times 2 is 1. So let's go ahead and plot these. Well, that's good. All right, so if we plot -2, -1, that means I go to the left 2, down 1. There's my first point. -1, -1/2. -1, -1/2. Right about in there. The next point is 0, 0. Crosses right through the origin. We knew that was going to happen, right? 1.5. So go 1 to the right and up 1/2. And the last one we have is 2, 1. So over 2 and up 1. We can go ahead and connect our dots. This would be a direct variation. So let's say, what example am I on? 6? 5? Example 5. Graph a direct variation through, let's say, the point 3, 5. All right. So let's go with point 1, 2, 3. 1, 2, 3, 4, 5. Okay, we need to know it has to go through there. What other point does a direct variation have to go through? 0, 0, absolutely. I put 0, 0, and I'm going to ask you to connect the dots. That's it. Okay? If we needed to write a direct variation equation for this, we would say y equals, how do I figure out what my k is? Y divided by x, or 5/3, and then x. All right, any questions? You guys want to use the next 15 minutes to get this done? All right, we are doing page 71, numbers 8 through 38 even. Yeah, go ahead.